Hello, this is session 17. This is the pre-test for chapter 2. And I put a few things on the board already for you. I ask you, if you don't have it already, to download that pre-test and take a look at what's going on. The first problem says to determine whether, find the vertex. Find the vertex of this parabola. F of x equals to negative 1/2 x squared plus 3x minus 4. Well, there are a few ways of finding the vertex. One is to complete the square. I think that's rather tedious. Instead, I'd probably try this method. The vertex is equal to negative b over 2a, and then comma f of negative b over 2a. Try it that way instead. Remember that a is the coefficient of the x squared term, that's negative 1/2, and then b the coefficient of the x term, 3, and c is a negative 4 we're not going to be using. Insert the negative b, the negative here of the 3, the numerator, and then 2a, the 2 times a is negative 1/2. And that gives us negative 3 over negative 1, and then when you simplify that, that's 3. So our x value for the vertex is 3. We need to find the y value. So insert the x back in here for finding the f of that function, f of 3 in fact. Put the 3 back in for x in both places. This becomes 9 times negative 1/2 is negative 9/2, and then 3 times 3, 9 minus 4. I changed the negative 9/2 to negative 4.5 to make it a little bit easier for us. And then negative 4.5 minus 4 is negative 8.5, and 9 minus 8.5 is 1/2. So it looks like we have a good answer here. Answer should be the vertex is 3, 1/2, number 1. Okay, so use that formula v, negative b over 2a, comma f of negative b over 2a. Gives you a good answer there rather quickly. Be careful with your arithmetic. Take your time. Watch the signs. Make sure you use big and minus signs. You don't use minus signs. Number 2 is a bit different. Asking, is negative 1 a 0 of the function? There are about 3 different ways of doing this. One is to factor it. That's kind of tedious to factor. I don't think I could even give that a try. Okay? So I don't want to consider factoring that. The next way might be to consider the factor theorem, the a0 over an, and that would give us, in this case, 2 over 1, and all the possibilities for that. The third method is to go ahead and use the remainder theorem, and I think that's probably the best, especially for small numbers like negative 1 or positive 1. So remember what the remainder theorem says. It says if you substitute this negative 1 for all cases for x, and if the result of this is 0, then there's 0 remainder, which means that this in fact is a factor, or in fact negative 1 is a 0, and x plus 1 would be a factor. So let's see what happens there. I'm inserting negative 1 in place of x in all the cases here. Negative 1 to the 21st, negative 1 to an odd power is negative, so we'll put negative 1 here. Negative 1 to the 18th, that's going to be a positive 1 times the negative 2 will give us a negative 2 there. Negative 1 to the 12th, that's going to be a positive 1 times 5, and positive 5. Negative 1 cubed, negative 1 times a positive 7 is negative 7. And negative 1 squared times 3, a positive 1 times 2 is 3, and the 2. What I've done is I've underscored the positive values, 5, 3, and 2, total of 10 there. And the negative values, guess what? How about 10 there too, okay? So 10 minus 10 is 0, looks great. Because we get 0 as a remainder, that means that the x plus 1 would be a factor and x minus 1 a 0. Looks good? Answer for this one, yes. Be careful. If you missed on the signs there and you said no, you lost 5 points. You want to be careful on this. Take your time. Make sure you have the signs proper and the numbers and all those good things. Number 3, is x minus 3 a factor? Well, the same idea as above number 2. This time we're looking at it as a factor. Remember, this is x minus h. So h is 3. So I would probably try to factor this again. It has 5 terms. Really difficult to factor, I'd suggest. So I proceed then. You could try, as we did above here, you could try the remainder theorem with a 3. 3 to the 4th, 3 to the 3rd. The numbers get kind of large. They're not so large you can't do that, but I thought instead I'd try by synthetic division. Because we're looking at x minus h is going to be 3. So I'll place the 3 outside here. And then you know the process from here. The 1 is taken here, and 3 times 1 is 3. Multiply, and then combine, 4. And then multiply, 12. Combine, negative 1. multiply -3, combine -4, multiply -12, and guess what? We get 0, okay? And since we get 0 on that, that means that this 3 is a root and x minus 3 is a factor. Answer again, yes. Now, don't assume that on the test they'll both be yes or both be no. It might be yes, no, no, yes, who knows what, but get the right answer, okay? And there's no particular format I have for this, so do a good job, get the right answers. We're going to proceed next to number 4. And number 4 says to determine the zeros of the function here. There are some options for number 4. I'm going to try the option that you know I would encourage you to try. We've tried that from day 1. I'm going to try to factor it. So I would suggest in all cases, if you can factor, go for it. The factoring shouldn't be too bad on number 4, I don't think. We'll check to see in a few minutes here. But take a look at it. If it seems like it might be factorable, try that. If not, then we have the other situations of the factoring theorem or the remainder theorem or synthetic division. So there are a few ways we can proceed with this, but I would always try factoring. I think for number 4, factoring is kind of nice. We'll give that a try in just a minute here once you get all this off. There are some benefits to having a nice classroom board. In fact, many classroom boards where you don't have to keep one there and keep erasing one. And in fact, making sure it's dry. Okay, off to number 4. Number 4 says to determine the zeros of px equals to negative x squared, negative x cubed plus 24x. I mentioned that factoring is the preferred method if you can do it, and that seems to be very easily factored. How about factoring negative x from this? And after that, we'll say we could probably factor this one also, probably not terribly necessary. Let's just go ahead and set them both equal to 0. And that means either the first one is 0, which gives us x is 0, or maybe the second one is 0, and maybe adding 24 to both sides. We save a little bit of time there. Take the square root of this, and how about 3 answers for us? Don't forget the plus or minus here. X equals 0 on this one, and also plus or minus rad 24. And then this is the point where I would stop and say, okay, how about radical 24? What's that become? I expect maybe you can simplify that on your own. And stop the recording for a minute and go back and check what's it simplify to. That should be 2 and 12, not useful. How about 4 and 6? Or radical 4, 2, and radical 6 remains, maybe plus or minus on that. And a 0. These should be the zeros of the function then. And 0 and then plus or minus 2 rad 6. We have a cubic equation here. We should expect at least 3 roots. And we do have 3 roots. Don't forget the plus or minus on that one. That looks kind of nice. I'm going to go ahead and try number 5 the same way, okay? 5 says the same thing. It says find the zeros of this one. This is p of x equals to 2x cubed. And minus 3x squared plus 8x minus 12. Now the other ones we had, number 2 and 3, they had about 5 terms. This one only has 4, and I'm thinking maybe we can factor this by grouping. So I'm going to give it a try, okay? I'm going to try grouping the first 2 and the last 2. 2x cubed minus 3x squared. And remember now, if there's a minus sign here, we'd have to accommodate that. There's a plus sign, so that shouldn't be much of a problem for us. A minus sign, we have to factor the negative, make sure the signs inside are proper. You should recognize the fact that I'd be asking you this question, is it factored at this point? And your answer should be no. No, because the plus sign, right? Factoring means parentheses and no sign. Just putting parentheses did not make this factored. But we can proceed a little bit further and say, okay, let's take a look at each of these underscored. And is there anything common here? There's an x squared common in the first. Let's factor the x squared from that. We're left with 2x minus 3. Our plus sign here. I'm looking at a 4, I would guess, in both cases there. Let's take a 4 from each of those. We're left with 2x minus 3 also. And before you proceed, most important property in math, distributive property, give it back, check to see. X squared times 2x, 2x cubed. X squared times a negative 3, negative 3x squared. Same thing here, 4 times 2x, 8x, and 4 times negative 3, negative 12. Looks great. And notice too that we do have something very nice. Both of these underscored have the same term, 2x minus 3. Let's pull the 2x minus 3 out, and what we're left with, and normally I'd be covering these with my hands and say, what's left? X squared plus 4. And since we're looking for the 0, we're just going to set that equal to 0. The first one, 2x minus 3 equal to 0, that's easy enough. I'll let you do that and yourself. Add 3 divided by 2. Looks like 3 halves should work there. Be careful with the second one. The second one, x squared plus 4 equal to 0. You want to subtract 4 from both sides. When you subtract 4 from both sides, it doesn't become a positive 4, it's a negative 4. I expect then to have you go through and say, take the square root of both sides, and you should know the square root of negative 4 is. Okay, I'll wait. I'm not hearing anybody. I don't expect really to hear anybody, but it'd be nice if we were in class I could get an answer from you. You should understand that to be plus or minus 2i. So we're looking at 3 halves comma plus or minus 2i. These are the 3 roots. And ask you to put in, if you would, the imaginary ones also, okay? Put the imaginary. We're looking at a cubic equation here. We should expect 3 roots. We get 3, one of which is real, the 3 halves, and the other 2 imaginary, plus or minus 2i. Okay, that's number 5. I'm not sure we can squeeze number 6 in here. I don't think so. So I'm probably going to have to erase that and come back and try number 6 back here. Now looking at number 6, it says, is x minus 7 a factor? Right. Again, I would probably try this the same way we've dealt the others. If it's a factor, if x minus 7 is a factor, you should consider what the number would be outside the bar on the synthetic division, whether it's going to be 7 or negative 7 there. We'll use that and use synthetic division. If it's a factor, again, we'll have 0 as our remainder in the remainder theorem, if we want to try that. Well, we'll have 0 as a remainder for synthetic division. So I'm going to try it by synthetic division, I think. And we'll take a look at that and see how well that works. And if it gives a 0 remainder, we're going to say, yes, it is in fact a factor. If we get some other number other than 0, we'll say, uh-oh, it doesn't work, it is not a factor. Number 6. Is x minus 7 a factor? And in fact, it says a minus 8. It doesn't say is it a factor, just if it's a factor, find the others. We'll do it the same way nonetheless, anyhow. We'll put a 7 in here. Remember, it's x minus 8, so we need a 7. Now, the function is p of x equal to x3 minus 6x squared minus 9x plus 14. Coefficient x cubed 1, coefficient x squared negative 6, the coefficient of x negative 9, and the remaining number 12. Before you start, I know you're interested in finishing quickly, take your time. Go back and look. 3, 2, 1, x0. If there's a blank in there, if it's x cubed, x squared, or maybe the number, you need to supply a 0. If there are no blanks, looks great. We'll go through synthetic division for us real quick. A 1, 7 times 1, 7. Combine 1, multiply 7. Combine negative 2. And after that, in fact, let me write the problem correctly. It should be a 14 instead of a 12 there. Okay. That's why I had you reading the problems. It's so much easier if you read them instead of me. Plus 14, in fact, is in the exercise there. Maybe a good point nonetheless. Make sure you copy the problem correctly, okay? And 7 times negative 2 is negative 14, and we get 0. And it had to be 0. If it wasn't 0, then it wouldn't be a factor. So even if I had that 12, they said, wait a minute, there's something wrong here. It should have come out to be a 0 because the problem says it is a factor. So I should get a 0 there. From this, let's reconstitute it. This is -2, this is x0, this is 1x1, and this is 1x squared. So we're looking at this reduced statement x squared plus x minus 2. We could go further if we needed to look for some factors here, but I think we can factor this directly. How about the x plus 2 and minus 1? Does that sound okay? Take a look, we FOIL that. The first 2x squared, the outside -1x, and a positive 2x is positive x, and the last -2 looks good. There's our answer. Do not solve this. Unfortunately, I get many students who tell me, oh, the answer is x -2 and x 1. That's great. That is the answer. But what's the question say? The question says, find the other factors. We're finished. Read the question. Make sure you've answered the question. That's enough. Stop. Okay? There we go. Number 6. And after that, we're pushing on to number 7. Number 7 says we're looking for the x and y intercepts. And again, just a matter of procedure here, not a difficult problem. Just knowing what to do, we're looking at p of x equal to x squared, and then x minus 1, and then x plus 2. We like to find the x and y intercepts. To find the x-intercept, we'll let y be 0. So let's just change that p of x, and let's call that a 0. In that case, then x squared would be 0, and x minus 1 would be 0, means x1, and x plus 2 would be 0, subtract 2, x and negative 2. So when y is 0, x becomes 0. When y is 0. When y is 0 right here, x becomes 1. 1 minus 1, 0. And when y is 0, x becomes a -2. -2 plus 2, 0.